I need to be like that. Who said that? Camila. Hello. Welcome everyone today. Sorry, but I see only myself, not the slides. Sorry.
Hi everyone watching on the vJUG. We are just going to sort things out. So where are these slides?
This over here.
No. Where are they on your machine? Because they are open up on a separate. This is a Windows machine. I'm not a Windows human.
I am not. This is not Windows. Don't tell me I'm Windows.
What is it? The actual slide deck. Is it in a Chrome browser?
This is the one.
Oh, you uploaded it. Oh,
yes.
Okay. I understand now. 1 second.
So as you can see, this is our first time collaborating with vJUG, so it's expected. So don't worry. I think now everything is fine. Yes, I can see slides.
Perfect. You should be able to click next.
Click next where? If I click here. But I have to click both. Okay. So welcome everyone on our monthly meetup. So this is LJC. How many of you are first time at LJC event? Wow, quite few. Nice. So if you want to know more about LJC, just find me and I can talk about hours about it. But let's jump. Who am I? And this. Yeah. So my name is Marcin. I'm long time London Java community member. Recently start to be involved more. And as I say, if you have any questions about LJC, just find me. So this is more important than me. Sorry, this is a bit clunky, but so today we will have two speakers. Our first speaker will be Nelson, and he will talk about reactive programming. Unfortunately, Nelson was not able to join us in person, so he will be online, but I am expecting great talk from him. And then we will have as a second speaker Dan. Dan join us from Israel, and he will talk about something new, exciting, infrastructure from code, not as a code, but from code. It's something new I'm really excited to learn about today. What are those? And of course, we as we know, we present this with vJUG tonight. So welcome everybody who is online as well. I hope this is the first time we collaborate, but not the last. I have to change this. So what these events are about? Some of you probably know this slide already, yes, but this is a community event. Is organized by us, run by us, and to be a success, it has to get help from us. So if you have any talk you want to, or anything you want to talk about, just submit your session over here. You can scan QR code for easier, and yeah, just help. And this is a great opportunity to start your speaking career, which I think is one of the most important skills if you want to climb the ladder, yes. As the sessions are recorded, so if you don't want to be recorded, just don't go around here where is camera. We do this for speakers, you know, to give them feedback like, hey, this is recording. If you want to watch and see where you can improve, this. Another thing, if you have any feedback related to the event, not the other one, sorry. So any feedback related, please scan this. Please scan this one. I would like to people scan, because, you know, if we don't get feedback from you, how do you like it? Then we don't know what to improve. Please. I give few more seconds for people to scan it. This is a very simple form, like 4 questions about the event, about the speakers and venue. So I would really appreciate if you can help us with this. Okay, I hope everybody, I can get back a bit for a while. Yes, as I already mentioned, this event is run together with vJUG. How many people know about vJUG? What is vJUG? So virtual is vJUG is virtual Java user group. It has been created many years ago. I don't know, year ago, 2 years ago. Yeah, it has been reactivated by our friends, Kim and Sam. So if you have any questions about vJUG, just ask them. But it's like if you have no way to get into the in-person events, just join vJUG because they have a great sessions and even better speakers than we can have. Yes. So this, the next one, and the event is supported by Devox UK. We have today again Sam and Kim. They are also involved in Devox UK. So we have 2 tickets to draw for the attendees of today's event. So there is like QR codes again. You can scan them, and if you look back, though this is the one. So for the chance to win the now people they just remove their phones. Come on. Maybe I should say that you have to fill the form to get the chance to win the ticket. Yes, and the conference is 7th to 9th May. It's a great conference. If you didn't win the ticket, there is also like a discount code. So for £75, yes, I think. It's a great event. I'm volunteering in that event for, I don't know, like almost 10 years. It's a great place to be, great session, great atmosphere. Really worth to join. RecWorks, again, I don't have much more time, so RecWorks is behind LJC Science. It has been created, yes. They are recruitment agency, but they are great. If you want to know more, just ask me. And obviously Microsoft Reactor, which hosts us, and we are grateful for that, because without companies like this, there won't be community as ours. And this brings us to the last one, which is about other sponsors or supporters of our community. Those companies are supporting us. If you want to support us or your company, just give me a shout as well, and that would be great appreciated. So that's all from me for now, and I think we will move shortly to Nelson, which is
Go live on the attack. Hello, vJUG. Hopefully people can hear me in the other room and we don't have a horrible feedback link. But I'm going to bring our first speaker, Nelson.
Right. Hi, good evening. Can you hear me?
Yes, I hear you perfectly.
Okay. All right.
Let's get started. I'm going to add your slides to the screen and take it away.
Okay. All right. Good evening, everyone. Please confirm that you can hear me and see me. Can everyone hear me?
Yes, everyone can hear you and everyone can see you.
Okay. Hi, good evening, everyone. My name is Nelson. I was meant to be at the in-person event, but for some reason I was denied entry. So we have to do this virtually. How do I know if everyone can hear me?
Nelson, I'll let you know.
How do I know if everyone can hear me? Can everyone hear me?
Yes, Nelson, everyone can hear you.
All right.
Tell you otherwise.
All right. Okay. Good evening, everyone. So, my name is Nelson. This evening, we are here to talk about reactive programming, how to unleash high performance and non-blocking APIs for real-time applications. So, a little bit about me. I'm a Java engineer with over 5 years of experience building in various industries, especially in the financial services space for about 3 years plus now. Um, I have some experience with microservices and distributed applications, and of course, cloud native applications. So, this evening we are going to be talking and discussing a bit about reactive programming. Um, Before we proceed, here's just a brief agenda. We are going to be talking about, of course, what reactive programming is, why we even bother about reactive programming, the core principles of reactive programming, and then how to build reactive APIs with Spring WebFlux. And then, which is my favorite part, we would go in and demonstrate a real-time reactive API with back pressure. Then once we are done from there, we will talk about, how to proceed for anyone who is here who after the call would think, oh, okay, maybe this is something we should try. So we'll talk a bit about how to proceed, and then if time permits us, we will go into Q&A. All right. So, what is reactive programming? I wish I could, I wish I could see everyone and basically ask a member of the audience. I don't know. Can is there a mic that I can hear? Is there a mic, or otherwise we can just proceed? Anyone? What is reactive programming? Is there a mic in the crowd? Is there a mic in the audience? Okay. Well, in the absence of a microphone, so let's just talk a bit about what it is. So, reactive programming is a paradigm, it's a programming paradigm, right? It's focused on asynchronous and non-blocking, event-driven processing of data, right? It simply enables our application to handle a high load of data with very few system resources, and it does this in real time. So it enables our application to react to data changes and events in real time. All right. So why reactive programming? Well, before we talk about why reactive programming, let us even discuss the alternative, right? The alternative, the traditional REST API approach. So I can see everyone. I assume that they are Java engineers here. The REST approach that almost everyone is used to. In that approach, once a request from our client hits our server, each request is fed to a very specific thread, right? That thread takes the request, goes to the database through a database driver, maybe an event handler, and attempts to get data from the database, right? Now, until it receives a response, it is blocking. It is not available to take on other requests. That is what makes it blocking. So imagine an application with a limited thread pool. That means that our application can only accept n number of requests per time, right? Because of that thread pool limitation. So what is a thread pool limitation, right? If we say that application at system startup, there is a thread pool limitation. Some pools are maybe 20, 30, depending on the system specification. So a thread pool limitation is simply the constraints associated with using a pool of pre-created threads to manage concurrent tasks, right? The number of issues, you know, if you have a fixed number of threads, there's resource consumption, there's thread contention, there's several blocking issues, there's tax rejection, you know, and then it's difficult to debug, right? If you've ever attempted to debug a multi-threaded application, you will realize that it is a pain. All right. So so why then reactive programming? It is effective in resource utilization, right? It scales well under load, and then it improves the user experiences. If you're a backend engineer, I like to just say this on the side: we are the ultimate UX guys. It's not the guys with, you know, where you say, oh, I'm a UI UX developer. No, there's nothing like that. As a backend engineer, you are responsible for the user experience of the application. It's not the person who designed it, right? So reactive applications are resilient, they are responsive, they are elastic, and they are message driven. Responsive because the system responds to data in real time. Um, it is elastic because it expands well under varying loads, and it is message driven. So what are some of the use cases of reactive applications? You would think about IoT, event processing, API gateways, and especially a microservice communication between services in a microservice structure. So let's talk a bit about the core principles. I had spoken before. It's asynchronous and non-blocking. It is event driven, and then it has a feature which I love so much: the ability to handle back pressure and events and data streams. So let's talk a bit about this. So instead of waiting for a task to complete, our reactive application simply continues execution until basically endlessly, using very little resource. Of course, it improves responsiveness, and it's resource efficient. Um, when we say it is event driven, it means that it uses an event stream where the individual system components react to emitted events rather than requesting them synchronously. Um, a reactive application has the ability to back pressure. So what is back pressure? Back pressure is simply a feature in reactive programming where a slow client has the ability to control the amount of data a producer is producing per time, right? We'll talk a bit about that later on. Okay. All right. So the reactive programming has, you know, core concepts, right? Streams, reactive streams. Mono is simply a data structure that receives 0 to n, that produces 0 to 1 item, and Flux is a producer that produces anywhere from 1 to infinity. I feel like I should talk a bit about the concept of back pressure. I had brushed over it when I started. So imagine data flowing through a pipe, right? The data flows water flows through a pipe without a valve, right? A fast faucet. It could
Nelson?
overflow a boat. Yes. Yes.
You've got a little bit of like a wind sound with your head, with your microphone. Do you know where that's coming from?
Hold on. I think there's a fan here. Oh, right.
Oh, that's so much better.
All right.
Amazing. And then Nelson, whilst I've got you here, we've actually got a question if you'd like to take it.
Okay.
We have a question from someone on YouTube, and they would like to know, have you experimented with structured concurrency APIs? It helps a lot, especially with the JDK 25 challenge. Have you managed to have any luck with that?
I didn't get the question.
The person wants to know if you've experimented with structured concurrency APIs.
Structured concurrency APIs. No, not yet. I haven't, but I know that it helps to manage parallel execution of tasks in a structured and controlled manner.
Awesome.
No, not yet.
Well, what we'll say is, yeah, if people have tried it out, obviously try it out and put some tests in vJUG. But otherwise, I'll remove that question off the screen. Anyone watching from the LJC in the other room, if you have any questions for Nelson, feel free to also put it in the chat. But otherwise, Nelson, I'll let you carry on.
All right. Okay. Please, if you have any question, please put it in the chat, and then I'll have the opportunity to take it. So I wanted to quickly explain back pressure. So back pressure is the ability for a slow client to control the amount of data it receives from a producer, right? So imagine water flowing through a pipe without a valve, right? You know, it keeps flowing into like a bucket. The bucket has no way to control the amount of water that flows through it, right? So back pressure is the valve that lets the bucket control that flow, right? In an example, reactive, there's a function that's called request. It takes a parameter n. It's simply the bucket saying I can only handle 10 more items or 15 more items or 16 more items, right? The back pressure ensures the publisher in this case respects this. Later on, I'm going to demonstrate it in real time. So what if you wanted to build back reactive applications right now? In the Spring ecosystem, Spring WebFlux is what is used primarily to build reactive applications. So the Spring Reactive framework for building non-blocking asynchronous web applications is not an alternative, I should say. It is not an alternative to Spring MVT. It is simply designed to handle concurrency workloads efficiently. I might also add the Spring WebFlux is built on Project Reactive and Reactive Strings. Again, it is not a replacement for Spring MVC, simply an alternative for very specific use cases. All right. So how does this work? How does this whole reactive thing work? When a request from our client hits our application for the first time, it gets into something that's called an event queue. So request 1, request 2, request 3, request 4. Now, the event loop goes through the queue and picks the event one by one, and processes it. Now, if it finds an event, if it finds a request with a blocking operation, it simply takes that event and registers a callback for that event. By doing that, it passes it passes it underneath, right? Once that operation is ready, it simply passes the result of that operation to the callback. This way, the event loop is available to take on more requests. So you see, this is the mechanism that ensures that our application is performant at all times. Again, I need to emphasize that the Spring WebFlux is not a replacement for Spring MVC, but an alternative for very specific use cases. So if you already have a project with traditional REST APIs, you don't want to change it except you have a strong case for it. So let's try and put all this together. In the reactive framework, nothing happens until a subscriber subscribes to an event. So the first step is a subscriber subscribes to a publisher responds with an unsubscribe event, basically just acknowledging that subscription. Then the next thing is that the subscriber fires calls the request function and passes in the amount of data it is able to process. Like, guys, this is the most important concept regarding getting back pressure, because this is the feature where the consumer is able to detect how much data it can consume from the publisher. Then, of course, on receiving that request, the publisher then publishes the data with the on next event, on next, on next, on next, until the end of the requested data, right? And then of course it would return an incomplete or on error event. Again, I need to emphasize that Spring WebFlux is not a replacement for Spring MVC. All right, let's do this. Okay, I'm getting to the part where I really enjoy. So this is a little a piece of code, a screenshot from a piece of code that I'm going to demonstrate in 2 seconds. This is simply the producer. I'm simply calling the find all method and simulating a producer that emits events at a very rapid rate. In this case, 500 milliseconds. And then, okay. So where do we go from here? We've introduced reactive programming. You Once you go back, you read about use cases, and maybe hopefully, if I was successful, you would consider integrating it in your application. So where do we go from here? The first step is to start really, really small, right? Identify non-critical endpoints, right? Something like metrics. If you have like an endpoint that provides metrics or notification to refactor reactively, you can convert like a notification stream endpoints to use flux. Then isolate the components. You do this by using WebFlux alongside your traditional web MVC in the same application, the same code base. And then eventually you gradually integrate the database. So for new features, you can use R2DBC with Postgres or MySQL. Then you have to remember to keep the existing JPA code. You can bridge it with Mono from Callable for blocking operations. And then please, guys, test as though your life depends on it before you ever attempt to use both the reactive approach and the traditional blocking approach in the same application. All right, so this is the favorite part, demonstration. Please confirm if everyone can hear me. Can everyone still hear me?
Yes, everyone can still hear you.
All right, okay. So I'm going to demonstrate a producer producing event at a very fast pace and a consumer consuming that event at a very, very slow pace. All right. I might have to change my screen for a bit. Give me a minute, guys. All right. I'm trying to pull up.
Okay, now so what you're going to do is you're just going to push the screen sharing button at the bottom where you shared earlier and just change to a different screen share.
Oh, great. Okay.
No worries.
Right. Okay, maybe we can just do this. So I built a little
So Nelson, you're still just
front-end
showing the demo screen.
application to I know.
Okay, cool.
I know. Okay. All right. Give me a minute, please.
No worries.
This is my
Again, for anyone watching, if you've got questions, pop them in the chat. We can get them over to Nelson. If we run out of time, we'll also get them over on the Slack. But we should have Nelson's other screen in a second.
All right. Okay. Please confirm that you can see my screen.
Yep.
All right.
You're perfect. You're good to go.
Okay. So this is a little HTML CSS thing that I did with just to demonstrate a consumer consuming data from a producer at a very slow pace, right? To the left, this is the size of the queue. So what I'm doing here simply is to just show the amount of data that is in the queue, and then total process will just show the number of data that the application would process. Don't worry, once I start the application, we would see this. Maybe I should just share my entire screen so that we can see this. Okay. Maybe I should just share my entire screen and share the code. Yes, let me share my entire screen. Share my entire screen.
I think that's a great idea. Oh, we got a friend.
Oh, hi.
Don't worry. Okay, we're sharing your entire screen now.
All right. Okay. So I'm going to start. This is a simple simple reactive application that I built just to demonstrate this. So I'm going to start this application. Let's see. All right. Please confirm that you can see my screen. You can see that the application is starting.
It's running wonderfully.
Okay. Give it a minute. So the application will start, and then we will go to the consumer and begin to request data from the producer. Right now, I need to quickly show that this producer is producing events at 500 milliseconds, and the consumer will be consuming these events at, say, 5 times slower. Okay, please confirm that you can see that the producer has started. All right.
Yep, you can see it all.
Now we would get here and begin to consume this. Please confirm that you can see that the consumer has begun to consume the events. On the left hand,
you can see
on
exactly what you can see.
Right. So on the left hand side, This is the amount of data that is getting into the queue, right? And pay attention to the pace, right? The producer is producing event at a constant pace, 500 milliseconds, basically, pop, 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 pop. But here, the producer, the consumer, is consuming this event at a very slow pace. Like at every point in time, you would see the amount that is processed and the current data that is processed, but both of them are putting now at very different paces. So this is what allows our application to continue to be responsive, to be elastic. It can scale well under any amount of load, and then most importantly, it is fault tolerant. If something happens, it will not break the flow. So the producer produces events at 500 milliseconds per item. This is the size of the queue, and then the consumer produces events at 5 seconds per event. So you see, this is the size of the queue. Now I'm going to do something very important. Now we are going to get into our producer and stop the producer from producing events, and let's see what happens. All right. So I will come here. You see, I'm also logging the all the events that are produced. So let's stop it. Shall we? In 5, 4, 3, 2, 1. Let's see. Come on. Okay. Yeah. Good. So pay attention. The last event that was published is 265 camping stove. All right. So see. So what is happening? Our consumer is still consuming the events. Basically, anything that was still left in the queue will still be consumed by our consumer. It will still process that event. So let's even say that what happened was an error, for instance, right? You see that the client, the front end is still responsive, is still alive. We might not wait for it to finish, but let's see. It is still processing events. The event queue now. So what is happening that it's taking the events from the queue and processing it. It goes back, takes it, processes. It goes back, takes it. And the process continues until the queue size would basically get to 0. Okay, so let's go back to um, all right. So we are gradually coming to the end of our talk. I'm trying to share my screen again. Give me a second. All right.
You just need to dismiss that audience window if you want to enter full screen.
Yes. Okay, so we've come to the end of our talk. My name is Nelson again. The code, both the front end code and the back end code, would be will be published on a GitHub repository that I would send to Masin. Thank you, everyone. Thank you. Of course, I cannot see the audience. Thank you, Masin. Thank you, RecWorks. I'm currently, as a matter of fact, I'm available for to collaborate on any job or task if you have anything interesting. Thank you very much.
Amazing. Thank you so much. That was an absolutely... Oh, there we go. We can see you now. Let's add it. The presentation to the screen. But I think that's all we have from Nelson. So for anyone watching on the virtual stream, Nelson can also be found in our Slack channel, and anyone in the other room, I'll come over there now. But what we're going to do is we're going to have a few-minute break while we change over speakers. So thank you for that wonderful talk from Nelson. And while we change over speakers, I'm going to say goodbye to both the virtual and the in-person humans. And we'll see you back here in about 5 to 10 minutes max while we quickly just change over speakers and get another slice of pizza. So we will be back. Wonderful, we're back. We're about to have Dan live on air, so I'm going to bring him onto stage. Dan, hello to everyone. Can you speak so I can hear you?
Yes.
Working perfectly.
Sure. Okay, great. Thanks. So good evening, everyone, and thanks for coming and staying. It's great to be here in person, although I'm not sure it's going to be as much fun as a remote session. Today, I'm going to speak about infrastructure from code and whether we can achieve this desired state of no operations. This is actually a conceptual talk, or an inspirational one, if you like. So basically, I'm going to present this concept and try to convince you it is a great idea. I'll do my best. So your feedback is highly appreciated. You can give it to me at the end or whenever you want. And if you do like these ideas, feel free to do whatever you want with it. Take it, copy code from me, whatever you need. I'm not trying to sell you anything. I'm just here to share the idea. But first, who am I to come here and dare to speak to you? So, as you can see, I've been around for quite some time. I started as a Java developer for a long time. Lately, been doing more of a cloud architecture, trying to innovate and improve software developer procedures, wherever I can find them. And actually, this talk is about one of these attempts. And AI, of course, we'll use some AI in this session as well. I think it's illegal now to have a session without mentioning AI at least 3 times. So follow me up on that. We'll start with a bit of DevOps history, because this idea is about reducing the dependency in DevOps. So we need to know what are the issues, and then I'll present the concept and show it to you. So before we start solving any issues, you have to know, where do you stand? I mean, how things are happening in your company, whether you are like 2 people startup in some garage somewhere, or working for a large company with a lot of dependency on DevOps teams. You should know that. You should know how you test, how you work locally, for example. If you have an application with a lot of microservices that don't fit in a single machine, do you work against a central environment? Do you do something else? How do you deal with changes? If you introduce a new database, so Neo4j was like one of the sponsors, so let's mention them. You want to add and start using Neo4j, for example. What's the procedures? Can you do it on your own? Are you dependent on other teams? And maybe most importantly, how long do you wait for operations to do the stuff you need? Well, I can share you what's happening in my company, and I think it's pretty common, although no 2 companies are the same, but there are similarities, I think, in most of the medium to large companies. So let's say starting to create an application. They do the design, they do development, they're starting to add in some resources, databases, cache, maybe some message brokers. And when they're ready, it can be an MVP, something minimal, or maybe something more evolved. They want to deploy it. So in this case, we approach the DevOps team. This is a real picture. And we ask for their help to create the deployment descriptors, the script, whatever they need to create, for example, a cloud environment, or whatever is needed to deploy the application at their own pace. Sometimes it takes a lot of time. And for every major change, for example, introducing a new service or a new kind of database, we have to do this process again and again. So there is dependencies and delays in the process, and we didn't like it. So this dream about no operation it's not a new dream. Actually, if you check Wikipedia, you can see it was coined in 2011, 14 years ago. And it's interesting to know that it only happened 2 years after the term DevOps was created in 2009. So I think that pretty fast, people realized that DevOps is great, but they wanted something more. It wasn't achieved yet. And there are good reasons for wanting to have no operations, right? It's maybe sounding utopic. Yes? Sure.
So you say like DevOps are expensive, but I think what you described is actually ops, which was like the old process, because for me, like DevOps is actually, that's what you explain now. Like I know that is in many companies, DevOps is called now like ops with cloud, basically, yes. So but DevOps is really related for me to no ops is actually DevOps work together.
Okay, first of all, not all companies are working in the cloud. Some are hybrid. I know that banks and government offices are working on-prem. It's not allowed for them to bring everything to the cloud. And some companies are moving away from the cloud and going back to on-prem. And I guess the name is less important about operations in general. It's called IT and operation and DevOps, etc. And by extensive, I mean that if you check, I asked ChatGPT to make sure, and the average salary of a DevOps engineer is higher than the salary of a developer, for example. And time is very expensive as well, because time to market is central. And I know that some developers hate the fact that they are not independent. They cannot take their own code and application all the way to deployment, which is also important. And I know there's the concept of you build it, you run it, but once there are other teams in the middle, it's starting to be hard to achieve that. And again, we're wondering whether we can make it go away. And it wasn't just us. I mean, there are a lot of concepts now to improve the burden of operations. I think the standard now is Infra as code, talking about YAML scripts for Kubernetes or Terraform scripts. And it's an improvement, right? Things are written now. It's not like an oral wisdom that goes from father to son. And now you can set standards and share knowledge between companies, have best practices. The fact that there are there's a strict syntax that you can parse and create, and now with AI you can auto-generate stuff, also helps. And of course, if it's a source code or a source code similar, you can put it in some source control and trace it, roll back, and most importantly, find who to blame, right? So this is an improvement. Sorry. But there are still a lot of drawbacks, right? I think you may have encountered some of them. Terraform and YAMLs are not too friendly for the developer. Let's see. I hope it's large enough. Maybe I can take it higher. These files can be, this is just a short example, but these files can be very long. And for the average developer, it looks like configuration, right? It's not code, really. So you have to get used to the syntax and really know what you're doing. What value should I put here? What's the meaning of this? I think another disadvantage, you might do major changes in your code, switch a database, add Kafka, for example, and nothing will happen in the deployment automatically, usually. So someone will have to do some work, and basically we are still dependent on DevOps teams. So the next step was Infra's. Okay, 2 people. That's nice. I can show you how it looks like. If you don't know, it looks like better than scripts. So you can define a S3 bucket here and roles and Lambda functions. Basically, any cloud service can be represented here. And it's not only CDK. There are lots of companies that try to encapsulate the deployment artifacts as code to make it easy for developers. And it's an improvement, but still maybe not good enough, right? Maybe more friendly, but you still need to know what you're doing, right? What are the cloud services that you can use? What are the parameters that you need to put there? Still a lot of manual work. So basically, you're still dependent on DevOps team, or you become half a DevOps engineer yourself if you want to do it on your own and still waste time. The last improvement, which is not that new, but still you can some portal and you can define, create your application in one click, maybe even deploy it in one click, based on templates that someone made for you. Anyone here is using developer platforms? Oh, just Martin. So not too common yet. And this is great, but nowadays, instead of just having a DevOps team, you also have a platform. That's one thing. And do you have a platform team?
So actually, I was previous company based on DCP, and in this one we use Backstage, but different.
Okay. So Backstage is actually a framework to build developer portals. So you have to configure everything and add the templates. You have to do a lot of work for it to happen. And templates are not dynamic, right? We talk about the disadvantage of the disconnection between your code and the deployment. So it still happens here. So if I ask this question, you probably know what I'm going to answer, right? Infra from code. What is that? I'm going to make a few claims here and hopefully convince you it can actually be a real thing. First of all, I think we can all agree that the source of truth is the code, right? It's not the deployment. Because if we add, again, say Kafka in the code, and this will trigger a change in the deployment in order for our application to work properly. If we'll add something just in the deployment, it will have no effect except spending more money in cloud cost, right? So this is the source of truth, the code. And I claim that the code holds most, and I was being like careful here, maybe all of the deployment info. For example, database information, right? And I'll elaborate on that in a second. But if these two claims are true, then we can do some sort of scanning on the code and configuration. When I say code, I mean code and configuration, and know about our runtime environment, the needed runtime environment and resources, so we can create the actual deployment information, either YAML or Terraform or whatever, CloudFormation. And this is the concept. Now let's go a little bit deeper. What can we know, right? I said that we can know a lot of stuff from the code. Think about your Spring Boot or Java information. We can know what database are being used, right? The connection strings. We can know about caches, whether we use Redis or Memcached or something else, right? If we use message brokers, RabbitMQ, Kafka, we can know that. APIs, we can scan the code, for example, and know all about the APIs that are out there, whether we use GraphQL or REST APIs. And for example, in the deployment, we can know that this requires an API gateway. If we have a front-end, let's say a React project, we know that we can use, or we should use CDN and DNS and other services that are related to that, right? And we can also scan all the services in a workspace, assuming they are working together, opening the ports and everything else needed to create an entire application runtime deployment. And I can go on with this stuff, but I'm sure that you understand the possibilities here. So we have a few advantages. Since we scan the code automatically and deduce the deployment and create the deployment automatically, DevOps are reduced to minimum, or operations are reduced to a minimum, maybe to oversee the process. No detachment between code and deployment, right? Everything is dynamic now. If I do a change in the code, I can trigger a change in deployment. So deployment is always up to date, right? We don't have any additional scripts. Actually, we do behind the scene. But for us, there's only code, right? Everything else is abstracted and hidden from us. And as a bonus, we can do something that we couldn't do before, and that to bind the cost to the code and not just to the deployment scripts. So we have a few advantages. And if we go back to the slide of the infra as code drawbacks, we can see that we handle, I think, everything. It is dev friendly, right? Because we only write code, and we don't need to know a lot about deployments and YAMLs and other stuff, because we just write code. The code can change independently. Not anymore. If we push any code change, this can trigger deployment change. And we're not waiting for DevOps anymore, right? Because everything is automated up to the runtime environment. Looks great. So your new pipeline might look like that. This is, of course, simplified, but when you push the code, we can do some stuff to make sure it's good enough. And then we do our analysis. We'll demo that in a second. And at this point, and you can add information and context about your company standards, for example, or any other limitations. Maybe you want to limit the machine sizes that are allowed to be used here. And then you can build whatever deployment script or information you need and actually deploy it, right? So no more DevOps in the process. Let's take this all back to Java, right? And I think Spring Boot is a sure bet. I think most of the Java enterprise deployments are still based on Spring. So if we look at annotations, we can learn about REST APIs, what GET requests, POST requests, etc. we have in our code, the path, right? So we can map that in some API gateway, for example. We know about JPA, repositories, and the queries, and whatever we need to know about our application interaction with the database, any data source, actually. We can, since this is Java, we can add custom annotation to give hints to the process that runs the deployment creation and tell them, for example, that we need a GPU for this code. Something's not always clear from the code, so we can always add hints if we like. Properties. I check, and there are hundreds of optional properties you can use in Spring, maybe even over 1,000. So you can imagine how many items of information you can deduce just by analyzing the properties. These are just a few examples. And of course, the POM project object model. You can know a lot about the jars and the libraries that you use. For example, what kind of database is being used in your application. Of course, it's useful to cross-check it with the actual uses in the code, because sometimes you leave libraries behind that you don't actually use, but this is doable. So we have quite a lot of information sources in Spring that we can look at and deduce all the needed information. The scanning can be done in at least 2 ways, right? We can write code like we used to do before AI and actually go through all the POM and the properties and the code itself and collect all the information that is needed. Or we can use AI. We'll try and show both ways. And this ChatGPT gave me decent enough results. So that's an option as well. And it helps because it is more dynamic. We don't have to support all the options in our code. We let some LLM do that work for us. And you might ask me, what about runtime? Because everything I've talked about happens in compile time, let's say, or build time. And my claim is that not many things are changed, not many important things or structural things are changed during write time, right? You hardly change the type of database at runtime. Never happens. So we don't have to worry about lots of this stuff. Some things do change. For example, you might need more memory, right? You might run out of memory or a more disk space. And that can be handled easily in at least two ways. Right nowadays, if you're running with Kubernetes, it does auto scaling for you, and it can take care of additional resources that you need, even disks nowadays. It has some new operators that will take care of that as well. Or you can do it yourself, although I don't recommend it, right? We have good enough orchestrators these days. Yes?
How do you configure the auto scaling in your code? Like, how would you tell it, well, actually, you're going to need this amount of memory or CPU, what stage you're going to scale up, all that sort of stuff. And I guess, how do you know what sort of limits you need?
Okay, so I have a few answers for that. First of all, repeat the question. Okay, he asked, how can I know how much memory will I need and how much disk space also, I guess, and how many resources at runtime. So I said I have a few answers. First of all, maybe you don't have to worry about that in your scanning because Kubernetes can take care of that for you. So you don't have to indicate anything. But like I said before, and I'll show it as an example, you can add an annotation, a custom annotation that gives a hint to the runtime, and you can tell it that you need a large machine or a minimum amount of memory. And if you're asking how can you know in advance, you can try and do some calculation, right, based on the data you load into memory and based on test running on your own machine. And it will never be accurate, right? So you have to bring some, give some upper limit and start with that. And if you have auto scaling, it's not an issue again. So I think it is covered.
We have a question from online.
Sure.
They would like to know if the code knows I'll be using PostgreSQL instead of MariaDB, does this mean changing infrastructure translated to changing code?
Well, I'm not sure I fully got it, but if the question is how do you know which database to use, then you can see it in the POM, and I'll show that in a second. There are few products, commercial products usually, that does something similar, but they are like in the neighborhood. They don't have anything that is exactly what I'm talking about here. For example, there are frameworks that help you, or products that help you run JavaScript application, let you deploy them in an easy way. I think the closest one is Nitric, but it's not infra from code, it's infra in code. They require you to actually declare the infrastructure you need inside your code. I need an S3 bucket here. I need some API gateway there. So it's still manual work. It's not very different from using CDK, for example. It's just embedded in your code, which might be even less convenient. So I didn't find anything that is exactly like that. Correct me if I'm wrong. You can, if you find something, please let me know. So I think I've talked enough. Let's see some stuff. Okay, so I have a small application here. And for example, someone asked about the database. From the POM, you can see, I'll make it even larger. Is it okay? Great. Okay. So you can see that we have a web project here, right? And some other libraries, and maybe a database, and even the type of database is indicated here. So this is regarding the question, how do we know the database? Of course, we can scan the code inside. And for example, I looked at the POM. I've used, I've used some Maven library that lets you parse the POM in an easy way, and you can look at you can have the model of the POM with all the parts, and for example, you can look for the data JBA starter expression, right? So if you have that, then you know that you're using a database. Let's see what did it find in. So it made a quick scanning and found out what I have here. It knows about the database type, image name. The CPU intensive is coming from actually a custom annotation I have here. Right? This is regarding your question. Right? Not sure it's needed if you're using Kubernetes, but you can take it to a GPU needed, or whatever you need, or minimum memory that you'd like to start with. Again, based on your local experiments. So that's another option. Or we can do it with AI, for example. Right? So I've prepared a nice prompt, making it feel good about itself, that is a very experienced Java Spring expert, and I've asked a few questions. Of course, this is just an example. I'll try and make this a little bit larger. So let's take the POM. And I've asked him a few questions. One of them is a trick question, by the way. Did it take the POM? Yes. Okay, so it knows about the database, and even give me some proof. It knows that it's H2. It knows that this is a web application. In the meantime, I'll take the next phase, and this all you saw that it's very verbal, telling me all stuff that I don't want, every stuff I don't want to know. So I can give it a template, basically, asking me just to get it in a JSON format with just the stuff that I need, telling me to tell me that if we have a database, true or false, etc., what database type, so we can make it shut up and give us exactly what we want. Still blabbering about. And I also asked him if we have a cache, and he was right about it too, because I didn't use any cache here. So it did pretty much, also giving me a nice summary table. That is very nice of it. But this is too much. So if we want to do it automatically, we probably want something more compact and more formatted. Yeah. It's extremely slow tonight, but it was okay, right? It told me the right stuff. It is a web application, and I'm using an H2 database, and I'm not using any cache. So it's also useful to do it for automated processes, but this is not enough. And I also want to deploy it. So we did the scanning, right? We know what we have in our application, but let's create a deployment. So I'll be using AI for that as well. Basically taking this information about what I have in the code and asking it to create me a YAML to deploy it in Kubernetes. Okay. This actually sends a request to OpenAI. I have the response here, but I need the indentation to be more accurate. So I'll take it from here. Sorry, tough time with the mouse. I think that would be enough. So let's take a look what we have here. Sorry about that. So it actually created a Kubernetes YAML with a deployment of some service. This is the actual image for the application, which I haven't built yet, but it knows about it. And since we have a web APIs, it also added Nginx, which is very nice of it. And since we have a database, it also added a stateful set for H2, which is great. And let's try to actually deploy it, right? I have a Kubernetes running locally here, a kind cluster. Let's see, I only have Kubernetes running and no deployment. So we can actually apply this file, and it actually did something, all the stuff that we see, and actually trying to run it, right? Nginx is already up. The IFC, it won't happen because I didn't build an image and pushed it to a registry, but if I had done that as part of a pipeline, it would be running as well. So what did we see, right? We saw the concept, and I hope I convinced you that we can know a lot of stuff about the deployment just from scanning the code, the properties, the POM, etc. And we actually created a deployment descriptor from it and deploying it. Okay, so again, like I said at the beginning of the talk, this is just a concept, but if you like it, you can take it to a real product and improve things. Thanks.
Yes. Oh, sorry. Thank you for the very interesting talk. It was super insightful. I have a question that I didn't quite catch the grasp on, let's say. So we can deduce a bunch of things regarding the configuration from the code, but this is sort of relying still on the assumption that your pipeline doesn't change. So if your pipeline has structural changes, like if you think of a cloud environment, if you want to expand to a different region, or if you want to expand to different accounts, how do you keep track of that configuration, and how do you use this for that?
Okay, if I understand you correctly, you're asking about some stuff that maybe cannot be deduced from the code.
Yeah, and also like if you have safeguards in your pipeline, like one-box deployments or bake stages or things like that.
So I think that you can add stuff while you're building the deployment. I said that you can add some context here. So maybe you have company standards. For example, deploy your database in at least 2 regions, maybe I don't know, a read replica or some other stuff. So you can add it to the context, right? There's the same way I asked ChatGPT or OpenAI through the API to create me a deployment for these items that I collected. I can add some more context. I can tell it, if you have a database, make sure the deployment will deploy it in at least 2 regions as part of a company standard.
Okay.
Not sure it will cover like 100% of the cases. Maybe you'll have to make it smarter, maybe 2 options, depending on the type of the application. And in this case, you can help it with some hints. But it still is a dynamic, and you won't need DevOps for every change and every time. They do have to declare some guidelines or some standards, which is okay, and those standards may change with time, but you don't need them for any deployment of the application or any change. So I think it's still a big improvement. And I'm not talking about killing all DevOps engineers, right? Maybe just reducing the dependency in them. You don't have. So you said that using CDK, you're doing everything yourself. So it still takes time from developers to learn CDK and deploy and fix things. It can still help.
Hi, I have a few things to add, like good presentation, by the way.
Thank you.
So I'll give you some insights that I could do well, like listening to your talk. The first one is you can extend this model not only to grab things from the POM, because let's suppose I have because the lad asked the question about CPU intensive applications. If I have something analyzing the logs, let's say in the same way that we apply to the POM, like we'll read the logs, we'll see the application is consuming too much memory. Then we can ask, like we can add in an agent to create this new file. Of course, it needs to be validated by a human, but you could expand on that, add in a new step on the pipeline, like the continuous feedback from an already deployed application. Regarding the the AI examples, I think we still need to do some work on it, because at least I'm kind of terrified of just grabbing all my configurations and just trying to chat GPT. Maybe we could add in a RAG or a system in between, just to sort out those properties that are sensitive to the company, just like passwords, like pretty much anything that I don't want, like a hacker from an enemy state, like to get the information, like doing some element, like some ChatGPT hacking and getting all the information, just like we already heard in the story. So another layer of security would be good, and again, I think that will reduce like the dependency on DevOps, but still we will need someone to take the lead. Let's suppose I'm deploying on Kubernetes, like I have an Amazon, like I run everything on cloud, and Amazon catches fire. I have all the deployments. I need someone that knows how to handle this stuff to get it sorted. And if that person do some changes, that's a question that I have. So how will we maintain I'll keep track of human changes, like going straight into the infrastructure and changing things by hand, and as opposed to the configuration that we produce automatically, because there will be a discrepancy at some point. So yeah, that's something that needs addressing. That I still don't know, but I would like your thoughts on that. But yeah, I just wanted to bring these few things to the table.
Okay, great. Thanks. So first of all, about the first thing, I think that the feedback loop is always beneficial, and it's a good idea to add feedback from runtime into this process. Regarding the model, remember that you can always run an LLM model on-prem, right? You don't have to send anything. Although if your other stuff is in the cloud, I don't see much advantage of just the LLM on-prem. Right? If you're sending anything or running anything on AWS or on Azure, then might as well run this too. And regarding the best practices or human intervention, I think you can use best practices from the current DevOps practices, right? So everything, or you should have as many things as possible dynamic, so no human intervention. And when there are scripts or stuff that humans add, for example, the company standards and context or any other stuff, you should track it in the source control as you do with anything else. And it applies the same for anyone changing the runtime environment manually, right? It shouldn't happen. Everything should go through the source and source control and the pipelines that you have. So best practices are best practices here as well.
Right, that's all we have time for today. I hope everyone enjoyed this live stream. Again, if you're watching from anywhere in the world that has a local Java user group, please reach out to us. We'd love to live stream your events to the virtual JUG. We love doing the events that we do, but obviously it is a lot of fun when there's physical humans in the room and us watching online. So thank you to all of you for amazing questions, and a special shout out to Simon, who is always in the chat and always saying great things. So hi, Simon. But for everyone else watching, our next session is a vJUG organized session, and we're going to be talking about LLMs can't optimize schedules, but AI can. And that is going to be Tom Cools. He's going to be joining us, so please tune in for that session. That is going to be on the 23rd of April. So we hope to see you there. But other than that, have a wonderful evening or day or morning, wherever you are in the world, and we'll see you again soon. Bye for now.